like to welcome everyone back to the afternoon session. There's an awful lot of you. I feel like we've grown in numbers, so that's fantastic, and for hopefully very good reasons, because we have a fantastic session starting this afternoon with herders. And also digital dashboards as well. So we're very excited about your digital dashboards. We're also excited about herders, but we're going to kick things off with Dr. Tom Coolbaugh, who's going to be talking about some of the research efforts at Ohmsett.
Thank you. So I get to be the person first after next. So
we're on our kindness. We're the kindest you can.
True. Now that I know that data point, I'm going to try to do that for the future. First of all, how many people have heard of Ohmsett before now? Okay, so that's pretty good. Of those who raise your hands, how many people have been to Ohmsett? That's still pretty good. Okay, so for those of you who don't know, Ohmsett, in fact, I've got a slide here for it. It's probably this next one. So it's a wave tech. It's in Leonardo, New Jersey. It's across Sandy Hook Bay from Manhattan. We look across, we can see where the World Trade Center was. It's an interesting place, but it's 200 meters long. It holds 10 million liters of seawater. Open ocean salinity is what we try to go for, about 30 to 35 parts per thousand. We actually take the water from Sandy Hook Bay. It doesn't get changed much. In fact, hopefully that water will stay in the tank for the next 5 to 10 years. We refilled it a couple of years ago. We took the tank down to just bare concrete. It was built back in 1974 by the US EPA. And it was actually done for different kinds of research, but then it was mothballed in the 80s. Now, does anybody know what happened in 1989 that might have changed the history of what this facility is? I call it the Prince William Sound incident. Other people might call it the Exxon Valley. I worked for ExxonMobil for 32 and a half years. At the time when that happened, I worked for Mobil, so it wasn't me. It wasn't But then we merged in 2000, and also that's part of my heritage too. Again, I worked for ExxonMobil. I retired 3 years ago, but I've been going to the Ohmsett facility since 2007, doing research for ExxonMobil on oil spill response technologies primarily. So I've been going there for quite a while, and when I saw a position was available, I applied for it. Then I let ExxonMobil know that I was retiring. And then I retired on July 31st, and I started here on August 3rd back into 2020. So I was retired for a weekend. So here I am talking about the facility. So again, it's primarily for oil spill response research, because after 89, the Oil Pollution Act of 1990 was created, and it created the need for a facility like this. So it's government owned. It's owned by the Bureau of Safety and Environmental Enforcement, which used to be the Minerals Management. That's split into BSEE and the Bureau of Ocean Energy Management back right after 2010 thereabouts. So BSEE owns it. We operate it on behalf of them. I work for a company called Applied Research Associates. So we're the contractors who run it. I've never been a contractor before, which is kind of an interesting role. ExxonMobil, you sort of knew you're getting paid no matter what. Contractors a little bit different. But anyway, 10 million liters of seawater. We can make waves up to a meter high. The challenging thing in some cases is it's 200 meters long, but it's only 2.5 meters deep, and it's about 20 meters wide. So ideally we would like to have made it deeper, but when the EPA made it, this is what it is. So it's an interesting facility where we do R&D testing. We also do training. We do other things. We do things with Coast Guard training. BP was there recently. Chevron was supposed to be there. So hopefully they'll be there in 2024. But we'll talk a little bit about what the facility actually does from a research standpoint, because it's kind of unique. The kind of things we do focus on, not surprisingly, are mechanical containment and recovery. I think we've talked about the tools associated with oil spill response. So these are the primary ones. Treatments such as dispersants, herders, other things. We don't do burning because New York and New Jersey don't like things on fire and blowing black smoke over. So we can't do that. Fatal effects transport, we have sensor testing. Generally, the water can be really, really clear. We filter it, we chlorinate it. We don't let things grow in it. Occasionally, after GOMRS, the Gulf of Mexico Research Initiative, people were wondering if we could do biodegradation studies in it, but no, it's chlorinated. We have an inline chlorinator that uses the sodium chloride from the salinity to generate hypochlorite. We found out we have this inline chlorinator that's electrochemically splitting sodium chloride. It failed last year, and all of a sudden it's like, well, why? Well, these units apparently they're good for 10 years, and they're replaced. There was a storm called Sandy that was 10 years ago. That's when they were last replaced, and we never really thought about checking it. So one day we didn't have chlorine anymore. But the scale of this, we actually added sodium hypochlorite, 15% solution. Normally what you get at home might be more like 5% bleach. This is 15%. We had a 2,000 gallons, so that's just kind of the scale that it is. When we loaded it with the water from Sandy Hook, that's actually fed also by the Hudson River, the East River, the Raritan River. So it's brackish. It's more like 20 parts per thousand. So we actually had to add salt to it. Again, the scale is, it took 160 tons of salt to get it back up to the scale we wanted. So it's about 10 tons per part per thousand. So that's kind of the scale that it is. So oil fading affects behavior, wave energy. We've actually started doing wave energy conversion studies. There's something called, well, there's the Pacific Ocean Energy Trust that's managed by the Department of Energy. We had a wave energy converter from the University College Cork, Ireland, there in May. So just putting it in the waves and just seeing, it's an oscillating column, an oscillating water column energy converter. So we did that for a couple of weeks. So we're looking at renewable energy as well. So lots of different things, sensing technologies. Again, if the water's clear, there's a lot you can do. When we disperse oil into it, unfortunately, that makes it cloudy sometimes, so we have to time things accordingly. Oil handling, we have 60,000 gallons worth of oil storage in our tank farm. Crude oils, mentioned the other day, we have Hoops oil, which is out of the Gulf of Mexico. We have some Alaska North Slope. We have some of the Bryan Mound oil, that's the Strategic Petroleum whatever it is, reserve. So we have some oil from that too. And we're going to be getting, has anybody ever heard of the Taylor Energy Platform that's in the Gulf of Mexico? I see one or two hands. So I think it was it Hurricane Ike that caused a subsidence, and this mudslide pushed the Taylor Energy Platform over, and it's been leaking for the last 20 years. So finally it's been capped off, or at least there's containment above it. So the oil's collected. It is weathered to the effect that it goes through the water column. So some of the light ends and the aromatics were removed, but there's no processing chemicals added to it. So it's essentially it's a new oil. So they collect about 1,000 gallons a week, or actually 1,000 gallons a day. But it's a relatively small spill, but it's been doing it for 20 years. So between the U.S. Coast Guard and BSEE, that oil is collected, and we're going to get about 10,000 gallons of it up at Ohmsett as a future type of oil as a reference, because it'll be a long term. Unfortunately, it'll be leaking for a long time, so we'll have this oil available for testing. And then we are starting to look at things like plastic pellets. We actually had somebody look at a mechanical containment recovery system, typically for oil, but could it be used for plastic pellets as well? As long as they're floating, the answer is pretty much yes. But as soon as it sinks, we don't want to put sinking plastics in our tank because it's going to get into our filter system and all that. So we'll talk about some of the specific projects that we've been doing recently. So with the sort of the renewable focus, especially off the coast of New Jersey, and I think off of Scotland and other places here, the wind energy offshore is something that's becoming more of a reality. Unfortunately, with that comes the oils that are used as the dielectric fluids, the transformers. So there's a potential new type of spill that could happen offshore. So BSEE right now is actually doing 5 weeks of study at the Ohmsett facility to see if dielectric fluids behave the same as a crude oil in the case of a spill. So can you still use the same type of equipment, whether it's mechanical skimming? In that case, there's a couple of things that they're looking at last week. So you can see that one is with disc skimmer on the sort of the right-hand side. The other is it's a brush skimmer, just looking at what works, what doesn't. Dielectric fluids used to be silicone oils, but that's kind of moved away. Now there are classes of esters, either natural or synthetic, and then hydrocarbon fluids as well. So it's not surprising that they probably behave very much like typical oils do, as long as they float. But it's the viscosity that really determines what kind of mechanical containment, at least the recovery system, works. In the case of the brushes, it's much better when oil is more viscous. It sticks to it, you can get it off more easily. When it's too thin, it just sort of runs right through it. I think that's what BSEE is seeing right now. Because the fluids are really about 100 centistokes, so they're really pretty fluid materials. But again, that's what we're looking at, and that's the bulk type of material. That's just something we've cordoned off inside the tank itself. We can make smaller test areas. That's actually in accordance with the ASTM. Based on the size of the skimmer, you have to have so much area around it. You have 3 inches of oil, and then you pump it down 1 inch, and you see how long it took you to do that, and then how much water you collected at the time to get the efficiency and the recovery rate. We also do laboratory-based testing of ASTM type, so American Society of Testing Methods, at least to see what kind of other things to do. There's a standard sorbent test, and that's what these are. Normally it's in just a pan. It's a 10 centimeter by 10 centimeter piece and you look at how much it soaks up, how much it holds on to. We've developed something where we can look at larger solar pads and actually start rocking it so it simulates some of what the open ocean might be. So that's what those are. This is actually from a post that was recently made on LinkedIn. And we try to at least keep on sharing what we do at the facility, because that's kind of what my job is these days, to at least go out and talk about the facility. So dielectric certainly is something to think about as we go forward. Also looking at sensing technologies, as I mentioned. In the last year, we've had several different studies. A LiDAR study was actually out of the Naval Research Laboratory. LiDAR looking down at the surface, trying to see if you can evaluate what the thickness of the slick is. We get the questions a lot of time as an oil spill response community, what have we done recently to change the technology? And if you look at skimmers from 20 years ago versus skimmers of today, they're kind of the same. There have been some big changes like the grooves in the groove drums, the groove discs, but also the fuzzy disc systems within the crucial skimmers, so it's surface area. That's actually changed a lot. But the physics of actually running that piece of equipment hasn't changed. But if we can tell where the thickest oil is in this, the case of a spill, you can at least put people and equipment in the right place. OSRL and others, well, now there are 727 base systems and 737 base systems. For delivering dispersants, you can get there really quickly. But for mechanical, typically, if you go out and you find out you're in the wrong spot, it takes a while to pick your equipment back up and go to where the right spot is. So if you knew where that oil was to begin with, in the thickest part, then we can deploy things more effectively. So that's really what some of this work has been about. So LiDAR was looking at oil slick thickness. Then when you collect, if you do mechanical recovery of an oily mixture, a lot of times you'll see a report of X number of liters or gallons of oily liquid was collected. A lot of times it's 90+% water and maybe 10% oil. Other systems may give you the opposite, 90% oil. But it's nice to know how much oil and water mixture that is. So this next one down with Patel was looking at a sensor, basically a capacitance sensor across it's a pipe with fluid passing through it. And depending on how that changes, they could calculate how much of that is water, how much of that is hydrocarbon. So again, it's a way of at least evaluating what was collected for a number of different reasons. If nothing else, just knowing how effective your system is. Oil under the ice, that has been a concern for a number of years now. Maybe less of a concern right now. But still, if you can see where the oil is under an ice sheet in say, an Arctic type environment, again, it tells you how to respond to it. So American University of Beirut came in, they have a capacitance sensor that sits on the top of the ice and then looks through and it can detect the oil underneath it. So the system on the left there it's more or less an aquarium that was fabricated by our crew. And you can actually, the way AUB did it was they put water in, they put oil in, and then they float a block of ice on it. The thing we suggested is why not support the ice on a shelf, add the water, add the oil, and then through that end valve, raise the oil and water to the bottom of the ice. So at least you can do it in a very repeatable method and then go ahead and measure. That ice is actually frozen. We had a Conex box that we could take down to 0 degrees, freeze the ice there. It was done back in May or June. So it doesn't matter that it's summer. And then they put it through a wood planer to give it that smooth finish. So you can do a lot with ice that's pretty much like wood. So that's what this box or that picture there, that's just under the tarp out by the refrigerator. And then a whole bunch of other sensors we've gotten, looking at laser light scatterers, looking at fluorometers, looking at silhouette cameras, just trying to see, especially you've heard about subpart J for the US National Contingency Plan. It's being changed. And part of what BSEE is looking at is what is the best way to evaluate how effective dispersion was. In the past, they used to use fluorometers, but sometimes that's characterized as the person who's out in the parking lot, underneath a light, trying to find their keys. Somebody says, well, is this guy? No, I lost him over there, but the light's over here. That's the way fluorometry is in a lot of ways. You have an excitation wavelength, and then you have an emission wavelength, and they don't necessarily always line up with the instrument you have. So we've got 4 or 5 fluorometers. This is just a rig here that has all of them there at the same time. And then we can disperse oil right on top of it. This picture here, and is there anybody here from Syntef? Good. Actually, Syntef is fantastic. But it's a prototype piece of equipment that is really, it's a silhouette camera. So it's looking at 3D measurement of oil droplets, air bubbles, and it can really tell you droplet size distribution. So brand new piece of equipment. it wasn't well in focus when it got to us. So this is one of our technicians. Actually, if anybody goes to Clean Gulf, you'll get to meet him. And this is our new electrical engineer from Penn State. This is Syntef watching sort of over their shoulder as they took it apart, adjusted the lens, put it back together. Then NJIT is over here. This is a woman named Ann Slaughter who works for BSEE. She's very well involved with dispersion. But NJIT is over here watching for the results. And it came back and it's like, that's close, we got to do it again. So they took it apart 5 times, got it back together, got it to work. Turns out later when they shipped it back to Norway, it was out of focus again. So apparently there's a set screw that's just not robust enough. So kind of things that they do, and we have a crew here who's not afraid to take things apart.
10 minutes.
Yep. Actually, I'm getting close. Emulsion formation. So weathering processes, you have evaporation, you have dissolution, you have dispersion. Emulsification is a big deal as far as oil sitting out on the water. Even if it sits in calm water, it does start to pick up water droplets. And for emulsions, you can get to the point where it might be 50, 60, 70% water. And as it does that, it still looks like oil, but the volume goes up, the viscosity goes up. And BSEE has been interested in how do we make stable emulsions for future studies. So you want to put it outside. You heard today about photooxidation. That's one of the processes that goes on that may change the characteristics of the oil. Again, waves, you get water incorporated into it, but it takes time to do that. So you can do it in the laboratory, but the thing that BSEE was interested in is can we do that on the water surface? Which is interesting because in this tank, it's outside, it has wind, it sort of blows it all the way, all over the tank. In the past, we actually have a spray corral system that just because of the water coming out of the surface, it keeps everything inside that corral. But that's not quite the same thing that we want if we want to do multiple emulsification studies. So this is a system that we developed last year. So these are open lanes of boom. And you can see the oil sitting inside 3 different samples. And over a period of time, you can see the emulsification on that bottom right-hand side. The quality of the oil changes. But the whole goal is to keep it in those lanes, even when we put waves through it. So you can see there are sprayers up in here. So there's sprayers on either end, the north and south axis. And then the booms keep it within. But at night we turn, and then you can see waves going through it in those few pictures. But at night we turn the waves off. We can keep the sprayers going, but still that oil would have a tendency to leave the lanes. So there's a thing that we call an ice eater. It's just an underwater turbine, and that's what those are. That is what on the top. They actually get, you can see sort of an upwelling there. They get situated at the north and south ends of the lane. So just that upwelling of water keeps everything within the lanes for an extended period of time. In fact, we kept that oil in those for about a week, and you can do it longer and longer and longer if you want to. And then just with a microscope looking at the emulsification as it went on. As it started, you got a pretty broad range of water droplets inside the oil. And the longer it emulsifies, you do get more of a homogeneous mixture. And that's when you start to see potential stable emulsion formation. So that's just another thing, just looking at how to keep things in a position in an external tank over a period of time. Because unfortunately, every time we put something on the water, the wind kicks up. It could be east-west, could be north-south. Oil's down at one end one day, you come back to the other end. So having something that can stay there for periods of hours to days, I think has been a pretty neat indication of the improvement of what we can do for the facility going forward. And then, as I mentioned before, the kind of oils that we do, we actually have a repository of quite a few different samples. In some cases, we have samples from probably some of you in the room that might have been sitting for the last 10 or 12 years, and we're trying to figure out what to do with it. So we may give a call sometime. In fact, we have some of the Chevron oil that came from Eagle Ford, I think it's shale oil. So we have that. So we'll hold on to that until you want it.
How much are you selling it for?
I don't know. When you get there, it might be gone. I don't know. But yes, we have a repository of a lot of different samples. Some are weathered. We have different weathering chambers. Typically you just pass air through it, and that takes off the lighter ends. Well, we use it's an 80-gallon water heater. So we've stripped all that out, put in different fittings, and we can bubble air and heat it and actually weather 40 gallons at a time to at least take out the light ends. But the kind of oils that we have right now, let's see what that actually says. Okay, so that's actually MC20 is the indicators there. MC20 is that the Taylor Energy platform oil. So MC, if you remember MC252, that's the Macondo well. MC just means Mississippi Canyon, that's the block MC20 is the block where that well resided. So that's MC20 oil. They've been working and we'll get about 40,000 liters of it coming in the next couple of weeks. We have 60,000 gallons of oil storage, but we don't want to cross-contaminate. So this oil is going to go someplace where it's kept by itself. And if you drive around, whether you're in Europe or anywhere else, you've probably seen these isotainers, Eurotainers. They hold about 7,000 gallons. We got 2 of them. They're brand new, 30,000 bucks a piece. But that's where we will actually put that oil. And then we will use those as more or less permanent storage tanks going forward. We have to clear a space in our tank farm because it still has to be in a secondary containment just in case they do leak. But that's, again, something that BSEE was really interested in, is having that capability of storing this oil. Because as it is now, the oil is collected by a company called Coolbaugh, and then it goes to a refinery where it does get processed. So now some of that's going to be diverted directly to us at whatever cost BSEE and the Coast Guard are working at. I don't know. I assume it's just the collection transfer. But anyway, longer term, it has that potential to be a long-term reference oil. Because again, unfortunately, it's going to leak for a long time. They closed off, I think, half of the individual feeders that came out of that well field, but half of them are buried under tens of feet of mud. And I think they've looked at it again and again and again. They haven't been able to shut those off. So that's why they decided to put this containment dome over the top. It gets transferred into storage tanks, and then they offload it once a week. So for us in the long term, we will keep on getting that. Yeah, and the properties of it, there's a NOAA report that it's about an API 26. So again, it's got a lot of consistency. Gina Coelho, who's somebody some of you in the room probably know, evaluated the oil a number of years ago. The properties are still the same. So it's a stable source of oil, as opposed to things like Alaska North Slope, the Hoops oil, the Hibernia oil collection facility. They're all blends. The same thing as the strategic oil reserve, petroleum reserve in the US. It's a whole bunch of blended materials, and hopefully it doesn't change much with time. This is going to be pretty stable for quite a while. And then just going forward, for both those of you who've been there, it's again, it's 200 meters long. It's got 3 bridges that sit on rails, train rails that we can move back and forth with cables. We can move it up to 6 knots. So it's more or less a horizontal crane. It's got 2 500 horsepower DC motors that move it back and forth. We can accelerate pretty quickly. But the main bridge is, to me, it looks like a New Jersey Turnpike toll booth. It's rusting. It's just old. It doesn't have a lot of space in it. So we're designing a new system, a new bridge, and that's what that drawing in the bottom left is. It's going to be made out of composite. It's going to have an expanded floor down below for the staff, and then the floor above that is for clients, visitors. It's much bigger, and it kind of looks out. It's got sort of sloped windows, and then the top has an observation deck. And again, if you've been there, there's about a 30-foot tall crow's nest, which when you're in it and you move quickly, it's not very stable. We're taking that down. And this will be the new observation, and it's going to be in the middle of the tank. Because sometimes we do optics work, and if you're looking at an angle, you have to do corrections for parallax. This, it's going to be right above it. So there's a lot of advantage to doing that. It's going to be pre-conduited for all the wires that come in. But it's really about trying to make it a more useful space for clients as well as the staff. We have another building that was called the Engineering Tower. To me, it's just R26. We gutted it because it has the views of Sandy Hook, the Atlantic's on the other side of that, Manhattan, and it was all wasted. It was carved up into little tiny offices. We took all those out, and that's what the space looks like now. When we took the tank down, we drained everything out. We took it to base concrete. We did ground penetrating radar. Because again, this is an old facility. It was meant to last 20 years. Next year is its 50th anniversary. So a lot of corrosion. This is an ocean environment with lots of salinity, lots of corrosion. We fixed lots of rebars that were 90% gone. We fixed all of that. In the meantime, it's got observation windows. So if you've been there, you can see in. If it's clear, you can see it. But it's got these plexiglass windows that we've taken out. They're 4, maybe 5 feet long by 2 feet. They weigh about 150 pounds. We've turned them into tables. So it's like because we replace them every time. So we've got to do something else with it. So, and then finally, I'll just highlight, we have cameras and we're trying to make much more remote accessibility. So if you can't make it, at least we can show what it looks like. So that's actually a view from my computer. We've got about 12 cameras that look at different parts of the facility, so we can record things and again share for people who can't go. Because during COVID, first of all, nobody came, and then post some of the oil industry downturn, the chance of sending 5 people, where we used to, you might just send 1 or 2 now, so the other 3 or 4 back in the office can still see what's going on. So that's what we're trying to do there. Plus I get to log on and see what the crew is doing. That's actually my son. He's the senior mechanical engineer there. So sometimes I'll call him and say, hey, I see you. And they say, oh, there's somebody staring at the camera. But no, it's trying to get things back up into what I would say is into the 21st century. We used to sort of target the 19th century. So I think we're doing better. But no, again, if you ever have a chance to come, it's definitely something we like visitors. If you're not a US citizen, it just takes a little bit longer. So you have to give us some heads up. So if you do come, we like to have visitors. The one last thing, the smaller wave tank. So we've got 10 million liters, 2.6 million gallons. It's too big for a lot of different things. So I'm looking to try to get a smaller tank. There's a facility, there's a company in Ireland called Ohmsett that makes smaller modular tanks. So if I can get one that's about 60 or 70 feet long, 4 or 5 feet wide, 4 feet deep, I can do fresh water. I can do almost anything in there. And when it's all done, it's only 20,000 gallons. We just dump it into the tank. Yep. And the tank will never know because it's 2.6 million. So, and then we just process it like. And with that, this is the kind of view we get in the morning these days. So that's the Atlantic Ocean sort of off in the distance. So with that, that's my Ohmsett update. And so please come and visit.
Excellent.